Using number 14 wire to tail out a 20 amp circuit wired with number 12 wire at a junction box is not permitted. The National Electrical Code, or NEC, prohibits the use of smaller conductors for tails in junction boxes. NEC Section 300.15 B1 states that the conductors used for tails shall not be smaller in size than the circuit conductors they terminate. Number 14 wire is not rated for 20 amp circuits. Overcurrent could occur, leading to overheating, fire, or damage to the circuit or devices. Stab-in connections are not as reliable as other connection methods. Number 12 wire is too large for stab-in holes designed for number 14 wire. Instead of tailing out with a smaller wire gauge, consider replacing the number 12 wire with number 14 wire for the entire circuit, including the outlets. Use proper connectors, such as wire nuts or push-in connectors, to make reliable connections. Alternatively, you could use a wire nut to create a pigtail of number 12 wire that connects to the receptacle stab-in hole. While not recommended, it is sometimes done to accommodate existing receptacles or other devices that only accept smaller conductors. However, it is important to exercise due diligence and ensure that the installation is safe and code compliant. When dealing with electrical circuits, adherence to the National Electrical Code, or NEC, is paramount to ensure safety and prevent hazards. One common question that arises is whether it's permissible to use a smaller gauge wire, such as number 14, to tail out a 20 amp circuit that is primarily wired with number 12 wire at a junction box. The short answer is no. It is generally not permissible to tail out a 20 amp circuit with number 14 wire when the main circuit is wired with number 12 wire. This practice violates the NEC and can create several safety hazards. NEC Section 300.15 B1 explicitly states that the conductors used for tails, which are short lengths of wire used to connect devices or fixtures within a junction box, must not be smaller in size than the circuit conductors they terminate. This requirement ensures that the entire circuit is capable of safely carrying the intended current without overheating or posing a fire risk. Using number 14 wire on a 20 amp circuit creates a significant safety hazard because number 14 wire is not rated for 20 amp circuits. The current carrying capacity of a wire is determined by its gauge, with smaller gauge numbers indicating thicker wires that can handle higher currents. Number 14 wire is typically rated for a maximum of 15 amps, while number 12 wire is rated for 20 amps. When a 20 amp circuit is tailed out with number 14 wire, the smaller gauge wire becomes a bottleneck in the circuit. If the circuit draws more than 15 amps, the number 14 wire will overheat, potentially melting the insulation and causing a fire. This is a serious safety concern that can lead to property damage, injury, or even death. In addition to the risk of overheating and fire, using number 14 wire on a 20 amp circuit can also damage the circuit and connected devices. The excessive heat generated by the undersized wire can cause insulation to break down, leading to short circuits and equipment failure. This can result in costly repairs and downtime. Another issue that arises when tailing out a 20 amp circuit with number 14 wire is the potential for improper connections. Often, receptacles and other devices that are designed for use with number 14 wire have stab-in connections, which are quick connect terminals that allow wires to be inserted directly into the device without the need for wire nuts or other connectors. While stab-in connections can be convenient, they are not as reliable as other connection methods, such as wire nuts or screw terminals. Number 12 wire is too large to fit properly into the stab-in holes designed for number 14 wire, which can lead to loose or unreliable connections. These loose connections can cause arcing, overheating, and even fire. If you find yourself in a situation where you need to connect a 20 amp circuit to a device that only accepts number 14 wire, there are several safer and more code-compliant alternatives to tailing out the circuit with number 14 wire. Firstly, you can replace the existing number 12 wire with number 14 wire for the entire circuit, including the outlets. This ensures that the entire circuit is properly sized for the intended current and eliminates the risk of overheating or fire. When replacing the wire, be sure to use proper connectors, such as wire nuts or push-in connectors, to make reliable connections. Secondly, you can use a wire nut to create a pigtail of number 12 wire that connects to the receptacle stab and hole. A pigtail is a short length of wire that is connected to the end of a longer wire to facilitate connections to devices or fixtures. By using a number 12 wire pigtail, you can maintain the proper wire gauge for the 20 amp circuit while still being able to connect to the receptacle stab and hole. To create a pigtail, simply strip the insulation from the ends of the number 12 wire and the receptacle's wires, then twist the wires together using a wire nut. Make sure the connection is secure and that the wire nut is properly sized for the number of wires being connected. It's important to note that while tailing out a 20 amp circuit with number 14 wire is generally not recommended, there may be some limited situations where it is permissible. For example, if you are working with an existing receptacle or other device that only accepts number 14 wire, and it is not feasible to replace the device or rewire the circuit, you may be able to use a short length of number 14 wire to make the connection. However, in these cases, it is crucial to exercise due diligence and ensure that the installation is safe and code compliant. This may involve consulting with a qualified electrician to assess the situation and determine the best course of action. When working with electrical circuits, it's always best to err on the side of caution and follow the recommendations of the NEC and other relevant safety standards. Using the proper wire gauges, connectors, and installation methods will help ensure that your electrical system is safe, reliable, and code compliant. Tailing a 20 amp circuit wired with number 12 wire with number 14 wire at the junction box is not permissible. This practice violates the NEC, creates safety hazards, and can lead to overheating, fire, or damage to the circuit or devices. Instead, you should replace the number 12 wire with number 14 wire for the entire circuit, use proper connectors, or create a number 12 wire pigtail to connect to the receptacle. Always prioritize safety and code compliance when working with electrical circuits to protect yourself and others from harm. Additionally, it's also important to note that electrical codes and regulations can vary depending on your location. It's essential to consult with your local building department or a qualified electrician to ensure that your electrical work complies with all applicable codes and standards. They can provide guidance on specific requirements and best practices for your area. When working with electrical circuits, it's crucial to understand the relationship between wire gauge, amperage, and circuit breaker size. These factors work together to ensure the safe and reliable operation of your electrical system. Wire gauge refers to the thickness of the wire, with smaller gauge numbers indicating thicker wires. Thicker wires have a lower resistance to electrical current, allowing them to carry higher amperages without overheating. Amperage, or amps, is a measure of the electrical current flowing through a circuit. It's essential to select the appropriate wire gauge for the amperage of the circuit to prevent overheating and fire hazards. Circuit breakers are safety devices that protect electrical circuits from overcurrents. They are designed to trip, or automatically shut off, the circuit when the current exceeds a certain level. Circuit breakers are rated in amps, and it's essential to use the correct size circuit breaker for the wire gauge and amperage of the circuit. When selecting wire gauges and circuit breaker sizes, it's crucial to follow the guidelines provided in the NEC. The NEC provides tables and formulas that specify the allowable ampacities for different wire gauges and the corresponding circuit breaker sizes. For example, number 14 copper wire is typically rated for 15 amps. Number 12 copper wire is rated for 20 amps, and number 10 copper wire is rated for 30 amps. It's essential to consult the NEC for the specific ampacities and circuit breaker sizes that apply to your wiring situation. In addition to wire gauge and circuit breaker size, it's also important to consider the type of load that will be connected to the circuit. Different types of loads, such as lighting, appliances, and motors, have different current requirements. It's essential to select the appropriate wire gauge and circuit breaker size for the specific load that will be connected to the circuit. For example, a circuit that will be used to power a large appliance, such as a refrigerator or air conditioner, may require a larger wire gauge and circuit breaker size than a circuit that will only be used to power lighting fixtures. When working with electrical circuits, it's also important to use the proper wiring methods and techniques. This includes using the correct type of wiring for the application, making secure connections, and properly grounding the circuit. Improper wiring methods can create safety hazards and can lead to electrical problems. For example, using the wrong type of wiring for an outdoor application can expose the wires to moisture and corrosion, which can cause short circuits and equipment failure. Making loose or unreliable connections can cause arcing, overheating, and even fire. Properly grounding the circuit helps to protect against electrical shock and equipment damage. Grounding provides a path for fault currents to flow back to the source, causing the circuit breaker to trip and shut off the circuit. This helps to prevent electrical shock and can also protect sensitive electronic equipment from damage. When working with electrical circuits, it's essential to take precautions to protect yourself from electrical shock. This includes turning off the power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment, such as rubber gloves and safety glasses. Electrical shock can be dangerous and can even be fatal. It's essential to take all necessary precautions to protect yourself from harm. If you are not comfortable working with electrical circuits, it's best to hire a qualified electrician to do the work for you. The electricians have the training and experience to safely and properly install and repair electrical systems. They can also ensure that your electrical work complies with all applicable codes and standards. The NEC is updated every 3 years, so it's essential to stay up to date on the latest code requirements. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA, or you can access it online through various resources. Staying informed about the latest code requirements will help you ensure that your electrical work is safe, reliable, and code compliant. In conclusion, tailing a 20 amp circuit wired with number 12 wire with number 14 wire at the junction box is generally not permissible. This practice violates the NEC, creates safety hazards, and can lead to overheating, fire, or damage to the circuit or devices. Instead, you should replace the number 12 wire with number 14 wire for the entire circuit, use proper connectors, or create a number 12 wire pigtail to connect to the receptacle. Always prioritize safety and code compliance when working with electrical circuits to protect yourself and others from harm.